Question of the Week from the Naked Scientists.
Hi and welcome to Question of the Week. I'm James Titko. This week Ranjit asks,
as gravity and time have an inverse relationship, at some time in the future, will astronauts bring back moon rock to Earth that will be, and I hesitate in asking this, older than the Earth? Obviously not. But why not?
Okay, I'm not going to lie, this has been a bit of a tricky one. I've been lucky though, as I'm able to enlist the help of Professor Ruth Gregory from King's College London. While you're right to point out that gravity and time are related, it's not exactly an inverse relationship.
What you're probably referring to, Ranjit, is the fact that gravitational fields affect the local passage of time, with time slowing down in a strong gravitational field, such as near a black hole.
For this theory, we have Albert Einstein to thank, who abolished the Newtonian idea that we inhabit a three-dimensional universe in which time passes uniformly throughout.
The effect we are discussing is known as gravitational redshift. It's an amazing example of how taking simple physical knowledge can lead to a deep result. We all know it takes work to climb a flight of stairs, and that's no different for a quantum of light called a photon.
Light comes in little packets, photons. If a photon loses energy, such as when it experiences stronger gravity, it increases its wavelength, and since the red end of the spectrum of visual light is the longest, we call this phenomenon redshifting.
What was remarkable about Einstein's intuition is that he realized this frequency of light was like the ticking of a clock. Think of a wave. From crest to crest is the wavelength, and the frequency is the number of crests passing per second. So each crest is like the tick of a clock, and a second for an observer deeper in a gravitational well would be longer than a second for someone outside the gravitational potential.
This effect has been verified experimentally, but the effect is so tiny for objects in our solar system, such as the Moon and the Earth.
It requires the supreme precision of atomic clocks to see. For example, the difference in a clock at the Earth's surface and one at the Moon is roughly a second in a human lifetime, and even over 5 billion years the difference is just a handful of years. So to answer your question, no.
So Ranjit, as I understand it, gravitational time dilation can equivalently be interpreted as gravitational redshift, during which photons losing energy in higher gravitational potential experience an increase in their wavelength, and thus a slowing down of the passage of time. The effect is so tiny in the context of the Earth and the Moon that sadly, you would not expect astronauts to ever be bringing back moon rocks which look visibly any older than they would be if they had been residing here. Hope that helps. Next week we'll be tackling this question from Malcolm.
My question is, how can we identify a disease? When looking at a sample of chromosomes, what are scientists looking for to spot a diseased gene?
If you have any thoughts on what we discussed today here on Question of the Week, please tweet us on @NakedScientists or log on to the forum on the website to join the conversation. If you've got any questions yourself that you'd like us to answer, send them by email to chris@nakedscientists.com.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.